Salutations, dear viewer. In a previous video, we looked at how to get started using Prettymaps in Python to create nice maps like this one. In this video, I want to go a little bit further and cover more ground on the nuances of what you can do with Prettymaps, as well as point you to some resources where you can go and investigate depending on what you actually want to do with Prettymaps. So let's get started. I'm here in this Jupyter notebook in Google Colab, and I'll jump over to the Prettymaps GitHub repository where we can look at this list of parameters on what you can pass into Prettymaps when you're building a layer. We'll cover a bunch of these, but really I'll be focusing on the layers and the drawing arguments for most of the video. The query string is what we looked at in the previous video as well. So it's either a pair of coordinates, lat long, or something that OpenStreetMap understands as a location. Query string. So that's what we would see up here when we plot our layers. We're passing something like the coordinate set or this kind of text string that OpenStreetMap can understand. Backup is an optional parameter where you can feed the output from a previous plot to save time if you're iterating on map development. Post-processing we looked at a little bit in a previous video as well, where you can apply a post-processing step to the layers dictionary. What does that mean? It means that you first created your layers, mapped them out, and then you do something to them afterwards. For example, here is an operation that looks at the layers array, grabs the dictionary, grabs the perimeter there, and adds a buffer of distance 10, returns that back. So what is this buffer here? Well, we can understand that better if we jump over to the Shapely user manual. So here, the Prettymaps is drawing on Shapely to do its drawing, and we can look at the manual for Shapely to understand what kind of methods beyond buffer we might want to call. So here we see buffer and the distance, and then other parameters we might want to do. Apply on it. We get good examples. We might want to do something else like simplify, get a convex hull, create a rectangular envelope on a layer, and other things. For me, my eyes, buffer is the most obviously useful one here. Maybe you want to simplify some map features. You can use simplify. Maybe some of these other transformations that you want to do, but this is where you want to look at the Shapely user manual. So I'll stick that in the video notes. So this post-processing is not a necessary step, but you can do pretty cool things with that. Another optional variable here, parameter, is radius. So in meters, what we see quite a lot used here. So here a map of Seoul is what this would draw with a radius of 5,000 meters. Melbourne here with 15-kilometer radius from the center point. Pretty obvious what's going on there. But then let's dive more into the meat of things with layers and drawing arguments. So with layers, we're creating a dictionary of all the layers and the OpenStreetMap tags to fetch. So I would say it's really key to understand what's going on in OpenStreetMaps to effectively build your layers and build nice maps. So let's look at an example. As we saw in the previous video, we create this dictionary here when we're plotting our layers, and we can give these variables any names we like in the dictionary, and we're giving some kind of information for them. So for example, we see that we're passing, creating these tags dictionaries in here for land use and leisure. We're saying that circle is false, dilation is happening at a rate we've defined, and street width is being defined. So a whole lot is going on as we define our layers, but how do we understand what that actually means? Well, I think the best thing to do is jump over to OpenStreetMaps and look at the layer features that are there. So I'm just on OpenStreetMaps, in a location, I can right click and query features, maybe look at a random building. And we'll see that there are tags here included already. So in this one, not very many tags exist, but we can see that in OpenStreetMap, this shape has been tagged to be a building. Yes. Okay, if we look at this church here, we'll see probably a bit more. A place of worship. Okay, so we get a lot more tags. So we get the city, even postcode. Building is not just yes, it's a specific building, a church. We get the name and so on. If we look at water features, we'll see a different kind of tagging. So we see that this is a water tap of type lake, and it's a natural formation of type water. So those are the kinds of information that we can pass on here. So when we're here defining what our building layer is in terms of OpenStreetMap features, this is telling it that anything where the building tag exists is going to be added to this layer. It's not going to be drawn as a circle, they're not going to be united to each other, they're going to be separate objects, and so on. Similarly for tags, this has parks, gardens, village greens, brownfields, and grass all there. So all of this will be rolled up into one layer that we've named green. So this is telling the renderer what are we picking out from all of the stuff there in OpenStreetMaps. Tags are the way to guide that. Streets, of course, the width is pretty straightforward. How many pixels should a different type of road be? So again, if you want to understand this better, maybe we can examine a road in OpenStreetMap and see there's a service road. So it's tagged as a driveway. A trunk road is a highway trunk, but it is a highway. So they should map over to what we see over here. Residential roads like this one, highway, residential, and so on. So we'll see residential roads here, highways not being rendered, primary roads, secondary, tertiary, and so on. So a really good idea is to get more familiar with the tagging system, with the layers as they exist in OpenStreetMap, where there's good and comprehensive documentation of how that structure works. So what can we then do with that? Well, one neat thing I want to show you is how you might separate buildings into different layers and then color them differently. That gives you more control over the kind of map that you want to create. So right now, what we've got is one layer for all the buildings, and they're going to be assigned colors from a palette we've defined here at the top with these hex codes. But let's say that we wanted to take some other buildings, specific buildings, and color them differently. Or maybe all the churches in our view, we might want to color differently. So I can look at the church again and see that there is a tag for churches. So this building is tagged as a church. If there are any others for our map, that will render that part like this. We can also get them on the same layer. So here, let's create that new layer and just call it church, and pick those up with that tag that we saw. So we just say building. Instead of being true, we just want to say if it's church. Replicate that false union flag right here. Have that comment at the end. So we're not changing the building layer because we still kind of want to pick every building. We don't want to. We don't always have residential buildings tagged as residential buildings. They're just tagged as buildings. But what we can do is first draw all the buildings and then draw these special buildings on a layer on top. Great. So then we need to jump over to the next set of parameters that we're defining, which are the drawing arguments. So in this layer section, we say these are the layers that we want to have an understanding of, picked out by these criteria. And this is how we want to draw them. So this is using Matplotlib as the library. So I'll look at the documentation in a bit, and we did cover a bunch of these things in the previous video, but here we can see that then you're passing on a number of parameters into each of these layers that we've defined, including background, which is always there, and specifying some things about that layer. So the fill color would be this one, the edge color of the background would be this one. If we want any hatching, any dots, any pattern to be on that layer, we define it here. And then we have the Z order, which defines in which order these layers are rendered. So the background will always be at the back, and the higher the number, the more towards the front or on top of each other will that layer be. So we've got buildings here on Z order 4. So if we want to draw church layer on top, we want to have a higher number there. And there are also other parameters we could pass here in the drawing quargs keyword arguments, which we can cover. But for now, let's create this church option. Basically, we can copy what's in the building section here and then tweak it. So let's start from here. Maybe the color would be quite dark. So we just say instead of a palette from the variable we've defined, we just do something quite dark. Edge color, keep it the same. No hatching. But critically, we want to have the Z order as higher. Okay, so let's make sure there are no typos. We've got it all nicely bounded. Instead of palette, let's use fill color, because we just have a palette of 1. And then if we run this, we've got any and all buildings that are tagged as churches colored with our new color. So we could use that and the tagging system in OSM to really customize our layers better. All right, what else can we do? Well, we can also adjust the transparency of the layers. That's one thing we can do. So we can adjust the alpha between 0 and 1. So if we had an alpha of 0.5, this should mean that we draw this last layer half transparent. So that might be something you want to do in some cases. Add some alpha there. So then we get the underlying color and this dark layer on top. And the third thing I just want to show is how you might change the way that the lines are drawn. They're solid lines by default, but since this is Matplotlib, this is using, we can also grab line styles that exist. So instead of solid, we might want to use dotted, dashed, dash dot, or even a custom parametered line style. So let's say we want a dash dot line somewhere. Well, I think it should be the perimeter. So we can just look at the perimeter variable here, say that we want the line style to be dash dot, and run this again. And there we go. The parameter that was a solid line is now a dash dot. So you can apply this to any of your layers and the edges there, the lines that you're drawing. And that takes us to the Matplotlib documentation, which in addition to the Shapely user manual and the OSM page is one of the 3 resources I'd really point you towards to look at what you can do with the Prettymaps and the layers there. So you can look at line styles or something else, whatever you might want to do, really depending on what you're trying to accomplish with your map. Remember that Matplotlib is the thing being used by Prettymaps to actually draw the layers by default, so you can understand line styles better there, and maybe other things that you might want to pass in here in drawing layers. All right, well, what next? Here, another thing we could cover is this trick of setting bounds at the end. So we've defined our layers, maybe done some post-processing, but we can also adjust the bounds here. So we've defined the axis up here, but let's say I want to push it a bit further away like I've done here. So it doesn't just go all the way to the edges. We can use this bit of code to grab, set the minimum for x and maximum for x and y, grabbing the perimeter bounds as they are, taking the delta, and then setting some multiple of that so that the axis gets set beyond that. So we can change the numbers and get a different result. For instance, so you can still kind of manually adjust things like the axis here. And I think that can make for nicer maps if you've got the boundaries nicely set as well. Okay, what else can we cover? So we looked a little bit more in depth in layers and drawing arguments. Always some credit. So this is the essential demanded by the license bit about where the data is coming from and where the code is that you do want to include in your maps as you create them. And you can adjust how that gets rendered. Often important if you want to make sure that it's not overlaying the map or some other text. So you can adjust the X value, the Y value, color, but remember you can also change the font, font family, font size, color, as we see here, things like that. So that's OSM credit. And fig size, we also looked at in the previous video. This is the optional width and height in inches for this Matplotlib figure overall, which is by default 10 by 10. Axis, we looked at title, just an optional title in terms of code for where that Matplotlib figure. And then VSketch. So if you have a pen plotter lying at home, maybe you want to create a sketch where everything is connected. So there's an example, the official example is this one, where it's using a whole different method. This is not Matplotlib, but instead VSketch. And what this gives is this line where everything's connected. So you can imagine a pen drawing this whole thing without ever being lifted off the paper. So you see this zigzag on the roads and streets and so on. So here we get this Barcelona thing. So I'll just point you to the example that exists here in documentation, not something I'm going to use, but this example works, and that's basically what VSketch seems to be for. Displacement, so if you want to nudge the map in a horizontal or vertical displacement direction, or stretch it out, scale it by X, scale it by Y, and rotate that. So you would just say things like rotation equals 180, or the X scale or something here. So that covers these parameters. I think there's still at least some trick that we see in the examples that would be great for you to know. I'm thinking of this custom text. That can be very handy. So here, this map of Glasgow's West End, we see the coordinates, latitude, longitude, or rather degrees and minutes, and then this title, which is pretty easy to do. Here's the trick. So we can pick any font we want if we've brought it into our file structure here. We set the location, give the text, give the color, give the rotation. Since this is on the left side, we of course want to rotate it to be vertical, and then assign any font properties we might want to see. So in this case, we grab the font from this file and set its size here. Similarly for the text on top. So you could do this for any number of things. And that gives us a nice little piece of text over here. Okay, so that's a bit of a whirlwind tour. Some of the things I've looked at and discovered here with Prettymaps. There's no doubt more you can do, given you can harness the power of Shapely and line styles, Matplotlib. But hopefully this was useful for you if you're working to make maps. If you're stuck on something, give me a shout, maybe I can help. But I do urge you to get more familiar with OpenStreetMaps and how the layers work, and take a look at the Matplotlib and Shapely user manuals and documentation to really understand a little bit more about what's going on under the hood here. And hopefully with all that, you'll be able to make beautiful maps exactly as you like them. So thanks for watching. Let me know what else you might want to see, and have a great day.